Good day, student. As you can see, what we have today is circle geometry. 12 congress circles are arranged as shown in figure 3b. What are the three radii of circles that, when drawn, will touch each of the similar circles at only one point, internally, centrally, and externally, respectively? So, I said that we are using three of the congress circle to illustrate what we are to do today. These circles are arranged. If you arrange them, they will continue to form a circle. The arrangement form a complete circle. 12 congress circles are arranged as shown in figure 3b. So these are three our illustration. We are using three to illustrate what we are trying to do, but there are 12 of them. So there we are arranged in such a way that the arrangement form a circle. So you are asked to, what are the three radii of circles that, when drawn, will touch each of the similar circles at only one point internally? Touch it internally. When you draw another circle internally, it will touch each of the similar circles at only one point, and then when you draw another circle from the center, it will touch the radius of the circles at only one point, and then when you draw externally, it will touch each of the circle at only one point. So when we come to that, so let's begin by solving it. So the first thing you have to do is you have to make some construction using any of the two consecutive circles. So let's use these two circles. Let's join their radii. Join their radii. This is a construction. You join the radii. So once you do that, the next thing you have to do is to give them label. Call here A, point at the center. Call here what B. So the next thing you have to do is to let's first of all solve for the radius, the central circle that will give us a radius of what? R. So let the center of that circle be somewhere here, and we can call it O, so that we can construct join AO. Join a line AO. Then join what? BO. Alright, once we have done that, the next thing you have to know is, we can say that AO, we can call what? AO. From here we know that AO is equals to what? BO, and we can say that is R1, which is, we can call it R1. In this case is the radius, we can call it a radius of what? Central circle that will be form. Central circle. So we call it the radius of the central circle when we draw it, when we join the centers, like this, joining the centers. So it forms a circle. So in order to find the radius of the external circle or internal circle that is formed, we must first get the radius of the internal circle that is formed. That is, we must first get the radius of the central circle that is formed. So, and because we are told that there are 12 of them, we started adding, and then form a circle. There are 12 of congress circle. Concrete means they have the same property. So now we have gotten this. What we need is to find this angle that is here. So because there are 12 congress circles, there is possible 12 of a type of triangle AOB that will be formed. So there will be 12, so that each of the 12 triangles, similar triangles of AOB, will have a central angle of 360 divided by 12, because there are what? 12 congress circles that join together to form a circle. So in this case, we have, when we solve it, we have the angle to be 30 degrees. So angle here will be 30 degrees. Then the next thing is, since we have gotten the question, maybe I will read the question again so we clean the board and have a space so that we can do it. 12 congress circles are arranged as shown in figure 3b. In this figure 3b, because we don't have enough space, we use only 3 because we are restricted with only 3, but 2 of the congress circles is sufficient to solve our problem. So what are the 3 radii of circles that when drawn will touch each of the similar circles at only one point internally? If we draw the internal one, we'll come to that, they will touch each of the similar circles internally only at one point. So if you draw it, it will touch it at only at one point. Sorry. So here it touches it at only at one point. No, I'm using a free hand. So this is just an illustration. We'll come to that for this internal circle. Then joining the outside of the internal circle, you get another circle. So we have how many circles now that will likely to be formed? The first is internally, the second is centrally, and the third is externally. So we will come to that. Now that we have gotten the internal angle, so the question is, what are the 3 radii of circles that when drawn will touch each of the similar circles at only one point internally, centrally, and externally respectively? So we are looking for the radius of the circles. I clear here. So once we have got the idea of what we are to solve, let me first draw this triangle so we can look at it very clear. The triangle is in this form. Here is O, AB, sorry. So we have gotten here to be 30 degree. So we will know that we get AB is gotten from joining the radius of the similar circles. So AB is equals to R plus R. That gives us 2R, and we know that R is what? Giving us 2 cm. So we have 2 times 2. So AB is equals to 4 cm, getting here to be 4 cm. So because we know that AO and BO are the radius, we call it A1, R1. They are equal because they are the radius of the central circle. So here will be R1 and here will be R1. Once we have gotten that, the next thing we have to do is to solve for R1, because this is 30. We can find these angles. So let's find the angles. So we know that we can find this angle because 2 angle, or rather, let me make it very clear, because you see they are equal. This side is equal to this side, and the triangle AOB is isosceles. Triangle AOB is an isosceles triangle, and we know the property of isosceles triangle. So for that reason, the properties of isosceles triangle, one of it here that we needed is that angle OAB is equals to angle OBA. The reason for that is that base angles of isosceles triangle, base angles of isosceles triangle are what? Are equal. So base angles of isosceles triangle are equal. For that reason, we know that 2 angle OAB will be equals to 180 minus 30 degree. This is angle AOB. So the reason is that the sum of angles in a triangle equals to 180. Sum of angles in a triangle sum up to 180 degree. So it must be given reason why you solve your questions. Solve the questions. So for that reason, this will give us 150 degrees, so that angle OAB is equals to 150 degree divided by 2. So we can find it to be 75 degree, and this is also equal to angle OBA. So this angle is 75 degree, and this angle is also 75 degree. Now we have gotten the angles. The next thing we should do in order to find the value of R1 is to make use of sine rule. Sine rule will be very fast for us to use sine rule to find the value of R1. So by sine rule, use sine rule. So by sine rule, we have that AO divided by angle what? Angle 75 is equals to AB divided by angle 30 sine 30. So because we know that AO is equals to what? AO is equals to R1. So in this case, we know that AO is equals to R1. Just cross multiply, have AB sine 175 divided by sine 30. So solve it. You have two ways to do that. You may leave your answer in short form, and we know that from here we can substitute our value. R1 is equals to AB is equals to 4 times sine 75. You can do the conversion immediately. Find sine 75 in sodic form. So when you do that, or use your calculator to find it, you have root 2 plus what? Root 6 from the calculator divided by 4, scientific calculator, or divided by what? Divided by half. Because sine 30 is equals to what? Half. So from here, you do your multiplication. You have 4 multiplying root 2 plus what? Root 6 divided by 4 times 2. So multiply it by 2, so that 4 can cancel out. Once you do that, you have R to be equal to what? In this case, we find R1 to be equals to 2 in bracket root 2 plus what? Root 6 cm. So either you leave your answer in this form, or you convert it immediately to decimal point. So in decimal point, you have 7.727 cm to what? 3 decimal place. So that is the value of the central radius of the circle formed by drawing a circle centrally. So we find that R1 is equals to what? 7.727 cm to 3 decimal places, or in sodic form 2 in bracket root 2 plus root 6, or in cm. So once we have gotten this, what next? We have solved the problem. So I can clean here. So let's go with sort. R1 is equals to 2 in bracket root 2 plus what? Root 6 cm. So how do we find the next radius, which will be internally, since we have gotten the central radius, which is the basic of all the radius we need? Notice, because it touched here at only one point, it also touched here at only one point, it touched here at only one point. When you draw it, very correct. So let's say, and from O, let's call this place, this point of contact, we can call it J. Is it not so? And OJ will become what? The radius of the internal circle that is drawn. So I call it R. So from here we have OJ to be equals to R. That is the radius of the internal circle. So let this be the radius of the internal circle. This implies that JO is equals to R, which is the radius of the similar circles, and we know that is 2 cm. So this means that OJ, which is R, so OJ, which is equals to R, is equals to what? AO. AO minus what? JO. So from here we know that R now is equals to AO, and we have gotten AO to be equals to R1, and that gives us 2 in bracket root 2. 2 in bracket root 2 plus root 6 minus what? JA, and JA is equals to 2. So all you need to do is to simplify it. You have R is equals to 2 in bracket root 2 plus what? Root 6 minus 1 cm. So this is the radius of the internal circle. This is for what? Central. So we have gotten the radius of the internal circle to be what? To be 2 in bracket root 2 plus root 6 minus 1. So let's clean here. So therefore OJ is equals to R, and that gives us 2 in bracket root 2 plus what? Root 6 minus 1 cm. This is for the internal circle. So the next is to find the radius of the external circle that is formed when we draw a circle or circumscribe the similar circle by drawing a circle externally which touches the similar circle only at one point. So in this case we now have to, mind you, this is a straight line, so you can draw this line. Notice that it will touch it at only one point. If we draw this very clear, it will touch here at only one point. That is what I'm trying to show you, so that we have another R here, and then we have OB, which is equals to R1, so which is also the central radius of the circle drawn centrally. So from here we can call here at this point of contact, we can call it K, so that we now have that OK, which is the OK, which is what? The radius of the external circle, radius of the external circle, and we can say that we can call it R2. Call it R2. So R2 is equals to OB. Is equals to OB, which is equals to OA. AO or OB. They are the same. So BO, and that gives us what? BO plus R. So mind you, AO is equals to BO, which is the radius of the central circle. So from here you have OK is equals to R2, which is there for external, and BO is equals to R1, and that gives us 2 in bracket root 2 plus what? Root 6 plus what? R is 2. So that R2, in this case R2 is equals to, you can simplify it, it gives us 2 in bracket root 2 plus root 6 plus 1, or in what? Cm square, cm, because we are measuring length. So this is what? The radius of the external circle. So we can click here and then we write it. In this case, okay is equals to r2. This gives us 2 in bracket, r2 plus what, r6 plus 1 cm. So this is for external. So I hope you enjoyed this lesson. Please, before you go, just click the subscribe button to encourage me to bring more videos for your view. If you haven't subscribed to our channel, please to our website, we are the least, we don't charge more. So with a token price, you can subscribe and become a member of manzananews.com, Manzana News Education Center, where you can learn mathematics. All you need there: geometry, calculus, statistics, algebraic, arithmetic, name them a few. Be able to master mathematics so that we are able to solve problems involving any area of mathematics in examination, in homework, or any exams you are to write. So if you enjoyed this lesson, please click the subscribe button. If you haven't have a Google account, Gmail account that will enable you do this, just Google it, Gmail account creation, follow the instructions and create a Gmail account so you can subscribe and also have inbox. If there is any message notification whenever we have a new update, we will send you a text. Share and like. I hope you enjoyed this lesson. See you in the next lesson. Bye for now.